Did you know that not all IP addresses are created equal? In this video, we'll uncover the difference between private and public IP addresses, how DNS translates domain names into IPs, and why NAT is essential for internet connectivity. Whether you're setting up a home network or troubleshooting connectivity issues, this is your ultimate guide to mastering IP addressing and DNS. Ready to optimize your network? Let's dive in.
Internet began to develop greatly from the 90s. With such growth, for a long time we've been short of IPv4 addresses. The solution to fill this gap is IPv6. While waiting for the implementation and development of IPv6, several other solutions have been developed, such as the NAT, CIDR, the VLSM, and private IP addressing. Hosts that want to be reachable from the Internet must have public IP addresses. The stability of the Internet depends on these public addresses, which must be unique. To ensure that the addresses are unique, their attributions are managed by IANA. With few exceptions, businesses and home Internet users receive their IP addresses from their Internet service provider. To cope with the accelerated exhaustion of routable IP addresses, the IETF published a standard reserving 3 blocks of private IP addresses for strictly internal use. This means that these private IP addresses are not routable on the Internet. Hosts roaming the Internet require a unique IP address, but private hosts that are not connected to the Internet can use any valid private address, as long as it is unique within the internal network. If you look closely, 2 networks are missing in Class A. The network in 0000 is reserved to define a default route on the routers, and the network in 127 reserved for tests local loop. Private IP addresses are not routed to the Internet backbone. All Internet routers are configured to eliminate routing to these private addresses. When a host who uses a private address wishes to go out on the Internet, then it will be necessary to translate this private address into public. This translation process is called the NAT. In general, it is the router or the firewall that takes care of the NAT. We will now talk about DNS. DNS allows the names of network systems to be converted into IP addresses, to be read by the machines performing the routing. If there was no DNS, you would have to remember the IP address of each host you want to reach. For example, to go to Google, just type google.fr. But if there had been no DNS, we would have had to remember to 74.125.206.994. To resolve names that are associated with their IP addresses, the DNS protocol uses a database that is hosted on multiple servers located across the world. An easy way to watch DNS in action is to perform in a command window ms-dos. The command nslookup, followed by the site for which you want to get the IP. The result of this command will give the IP address of the site, which also allows you to access it. You can check your TCP/IP settings by clicking on Property of your IPv4 Internet Protocol for a Windows PC. To end the course, we will talk about the command IPCONFIG, which allows you to display all the TCP IP configuration values of the network. This command should be launched in a window ms-dos if you are on Windows. By using different command options, it is possible to display different parameters. Used without options, the command displays only the IP address, the subnet mask, and the default gateway. Among the options we have the /all, which will display the TCP, IP, complete all network adapters, including DHCP and DNS configuration. The /renew allows you to renew the DHCP configuration of the network card. This option can only be used if the card is configured with automatic allocation of the IP addresses. The /release is used to obtain a new IP address from the DHCP server by sending a message such as DHCP release. This parameter deactivates the TCP/IP card, the time to obtain the new IP address. The options renew and release are very similar. The renew goes further and is the most used command. The /display DNS displays the contents of the host's DNS cache. When a DNS query for a host name is executed, the result is cached to avoid unnecessary queries. The /flush DNS removes the DNS cache from the host. This is a very useful option, especially if the host name has changed. And the /? displays help on using the command. On a Linux operating system, the command similar to IPCONFIG in Windows is ifconfig. The command man ifconfig displays all the associated parameters. This is the equivalent of IPCONFIG /?